Hey guys, so in this video we will be going over linear equations in two variables. So a linear equation in two variables can be written in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So for example, 3x minus 5y equals 10 is a linear equation in two variables where a is 3, b is negative 5, and c is 10. Another example is y equals 1/2 x plus 7, and this equation can be written as ax plus by equals c after some rearranging. And then another example is x plus 0y equals 8, where a is 1, b is 0, and c is 8. This is the same as x equals 8, and we say that this equation is in standard form. So solutions to equations in two variables will be expressed differently than solutions to equations in one variable. But we are going to need to first go over ordered pairs and how to plot them. So we use ordered pairs to describe the location of a point in 2D space, like a plane. We start by graphing a horizontal number line, and then we plot a vertical number line through 0. And we have them both intersect at 0. The intersection point is called the origin. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. And we call this system the rectangular coordinate plane. Notice that the system is divided into 4 regions. These regions are called quadrants, and quadrant 1 is located in this region, and we use Roman numerals to denote this. We number the quadrants counterclockwise, so quadrant 2 is here, quadrant 3 here, and quadrant 4 here. So we can describe the location of points by ordered pairs of numbers. First, we list the horizontal, or the x-axis measurement. Then we list the vertical, or the y-axis measurement second. Okay, so let's try graphing an ordered pair. Consider the ordered pair 4, 3. We start at the origin, and the point for this ordered pair is located here, where we go 4 units to the right on the x-axis, and then 3 units up on the y-axis. Okay, let's consider another ordered pair, -2, 5. -2 is the x measurement, so we're going to go to the left 2 units. And 5 is the y measurement, so we go up 5 units. So starting at the origin, we go to the left 2 units, and then up 5 units. So our point goes right here. Okay, so let's see how we can use ordered pairs to express solutions of equations containing two variables. So an equation in two variables, such as 2x plus y equals 8, has solutions consisting of two values, one for x and one for y. For example, x equals 3 and y equals 2 is a solution of 2x plus y equals 8. And let's check this. So we substitute these values in and check if it is a true statement. Simplifying, we get 6 plus 2, and then 8 equals 8, which is a true statement. Therefore, x equals 3 and y equals 2 is a solution to the equation. We can write the solution as an ordered pair, writing the x value first and then the y value second. Okay, so an ordered pair is a solution to an equation in two variables if replacing the values of the ordered pair results in a true statement. By the way, 3, 2 was not our only solution to 2x plus y equals 8. Let's try 5, -2. So plugging in these values, we want to see if we get a true statement. Simplifying, we get 8 equals 8, which is also a true statement. Therefore, x equals 5 and y equals -2 is also a solution to this equation. Okay, let's try an example. We want to complete the ordered pair so that it is a solution to the equation 3x plus y equals 12. For part A, we have the x value given, and we need to find the y value. So we plug in the x value into the equation and solve for y. We get y equals 12. So our ordered pair is complete. For part B, we have the y value given, and we need to find the x value. So we plug the y value into the equation and solve for x. We subtract 6 from both sides of the equation, and then divide both sides by 3. And we end up with x equals 2. And our ordered pair is now complete. So we can also express solutions as a table of ordered pairs. We divide our table with x and y in each column, and the ordered pairs in each row. Another way to express solutions to a linear equation in two variables is with a graph. So consider the equation x plus y equals 4. Some solutions include 2, 2, 0, 4, 4, 0, 1, 3, 3, 1, and many more. So let's plot these ordered pairs. Now, notice that the points appear to lie on a line. Let's draw a line connecting these points with arrowheads at the ends. Therefore, any point on this line is a solution to x plus y equals 4. Let's do another example. So to graph this equation, all we need is 2 points to draw a line. So we need to find 2 ordered pairs that are solutions to this equation. Let's organize our ordered pairs with a table. Start with picking any value for whichever variable you'd like. Maybe we can choose 0 for x and then solve for y. Then for the next ordered pair, maybe we can choose 1 for y and then solve for x. All right, let's start with the first point. We plug in 0 for x and then solve for y. Simplifying, we get 2y equals 4, then divide both sides by 2, and we get y equals 2. So our first point is 0, 2. Now let's figure out our next point. We plug in 1 for y and solve for x. Simplifying, we get negative x plus 2 equals 4. Subtract 2 from both sides, and since negative x is the same as negative 1x, we divide both sides by negative 1. And we get x equals negative 2. So our second point is negative 2, 1. Now that we have 2 ordered pairs, we can graph these 2 points and draw a line going through them. And this is the graph of the equation. By the way, notice how the line crosses the x-axis at the point negative 4, 0, and it crosses the y-axis at the point 0, 2. We have a special name for these specific points. This point is called the x-intercept, and the other point is called the y-intercept. So let's explore this a little further. The x-intercept of the graph of an equation is the point where the graph intersects the x-axis, and the y-intercept of a graph of an equation is the point where it intersects the y-axis. Let's go over how we can easily find these intercepts. To find the x-intercept, we let y equal 0 and solve for x. To find the y-intercept, we let x equal 0 and solve for y. Let's try an example. We want to find the x and the y intercepts for the equation x minus 3y equals 6, and we want to graph the equation. So to find the x-intercept, we let y equal 0 and solve for x. So plugging in 0 for y, we end up with x equals 6. So our x-intercept is 6, 0. Now to find the y-intercept, we let x equal 0 and solve for y. So plugging in 0 for x, we end up with negative 3y equals 6. Divide both sides by negative 3, and we get y equals negative 2. So our y-intercept is 0, negative 2. Okay, now we can graph these 2 points. We plot the x-intercept and the y-intercept, and we draw a line going through the points. So this is the graph of our equation. Sometimes you may see equations like this. If it helps, we can rewrite these equations like x plus 0y equals 2 and 0x plus y equals 5. Since 0 times y is just 0 and 0 times x is also 0, this is the same as x plus 0 equals 2, which is just x equals 2. And the same thing for 0 plus y equals 5, which is just y equals 5. That's why we can rewrite the equation in this manner. Let's go over this with an example. We wish to graph the equation x equals 3. Again, this can be written as x plus 0y equals 3. So x equals 3 just means that no matter the value of y, x is always equal to 3. So if we write out our table of ordered pairs, x is always 3 for each ordered pair. We can just pick any value for y, since it will always get multiplied by 0 anyway and get eliminated. For example, let's check the second point. Plugging in the ordered pair 3, 1, we end up with a true statement. Okay, so let's plot these points. We can draw a line going through these points, and we end up with a vertical line. This has an x-intercept at 3, 0. This will always be the case with an equation written this way. Let's write down this property. If a is a constant, then the graph of x equals a is a vertical line going through the point a, 0. The next example is a similar case of this. Let's try graphing the equation y equals 2 this time. Again, the equation can be written in this form. So y equals 2 means that no matter the value of x, y is always equal to 2. So our table of ordered pairs will have y always equal to 2, and then we can pick any value for x. Plotting these points, we have the following graph, which is a horizontal line. And there's a y-intercept at 0, 2. And this will always be the case with equations written this way. So let's also write down the property for this one. So if b is a constant, then the graph of y equals b is a horizontal line going through the point 0, b.